Okay, so I just want to talk through this surface area activity. So one, this get out the nets in this part one here. First, a net is this, you'll recognize it. I'm going to go down to the last page and you'll see a few nets, right? So usually I post this before class, but so you have this kind of thing that like this figure A will clearly make a cube when you fold it up. So if you can have a printer, you can print this out and cut it out just along these lines, like around the outside, right? And if you don't have a printer, you can just draw it. I mean, neither of these are very complex shapes. Um, just to make nets so you can understand how they make these three-dimensional figures out of flat spaces. So we use nets to conceptualize the idea of surface area. So the area of this flat space, that's all of this, filled in with these 1, 2, 3, 4, 5, 6 squares, is the surface area of the cube, right? It's the flat areas that go around the surface or on every one of the faces. And similarly, this flat area of when I add these two triangles and then these three rectangles, and I just want to make sure these three rectangles are not the same size. These two on the end are, and then this one in the middle is a different size. So be careful when you're calculating the surface area. But that's the surface area of this other shape, which is not quite a pyramid because it doesn't have these sides, but of this three-dimensional figure, right? Okay, so we have, so part one says get those nets, those two nets that I just were talking about, and find the area of each individual part and then record the areas, right? And so you'll add those up, and those are the surface areas of those shapes, right? And then the next part is to draw your own nets, like to kind of, so the first activity is to take these flat surfaces and fold them up. And this next activity is to take this three-dimensional figure and unfold it. And especially in this activity, you're practicing what we call like spatial reasoning or spatial awareness, which is really important as kids move into certain disciplines like into engineering or any sort of thing like architecture where they have to create kind of like flat drawings that really represent three-dimensional spaces. And this sort of reasoning can also be really important in word problem drawing. So if you've ever had trouble kind of drawing a picture for word problems, some of that is wrapped up in this spatial reasoning. So you'll draw this net. Again, be careful here because this perpendicular height here is 3 centimeters, and that is a different length than this guy right here, and you need to use the Pythagorean theorem to find the length of that side, which will be one of these rectangles when you unfold this. Okay? Similarly here, let me see, that's this 5 is the height of this triangle. That might be it. This is the height of this triangle. This 4 centimeters is just the actual height of the whole pyramid, but this 5 centimeters is like the slant height of the pyramid, which actually ends up to be the dimension you need for surface area. So you can draw that surface area and find the surface area of these two figures with nets. Okay. Okay, so then for problem 4, there are some reflection questions here. For problem 4, we'll draw the surface area or a net of a cylinder. And honestly, I mean, like some of these nets, they're like stay connected. You can think about just breaking the surface area up. So this one has 2 circles, top and bottom, right? And those dimensions are really like this, where it's just the radius, and that's all I care about to find the area of this, because the area of those is pi r squared. right? And then I have this lateral, kind of what they call the lateral area, which is the kind of part of the can that's on the sides, right? The side. And if you think about that kind of as a tube that's, okay, pretend like, right, this is like a tube that's like that. If you unroll it, it should unroll kind of like the label on a can of soup as a flat rectangle, okay? And if I have drawn that here and I'm thinking of this side as like maybe the edge of the label, does that make sense? Where you start to peel it, and that's H. And then the goal here is to figure out what this is, right? But this line here, this width of this is also the piece that gets wrapped around here. So this is related to circumference. So I'll let y'all think about that. Circumference. But like those are connected quantities. So to find the area of this rectangle, it's still width times length, but you need to put that like you need to put that in terms of R and H. So in the final formula for surface area of a cylinder, it only has R and H in it. It doesn't have any like width or length in it. Okay, so I'll let you do that. And it has questions about like the circular ends and the lateral side. We talked about that. And then asks you to find the surface area of this example problem. So this is kind of a mix of like the things that we have been doing. So then in class, we'll talk about kind of a general way to develop the surface areas. It's mostly by breaking down surface area into, or breaking down these faces of different three-dimensional shapes into their associated two-dimensional shapes, and then just using area formulas. Okay, so let me know if you have any questions.